Hey class, today we're going to go over the study guide for our exponents test that we're going to have tomorrow. Now the first two rules are actually the last rules that we just learned. We want to address them first so that as we go through the study guide, we can make sure that any negative exponents or any zero exponents we get, we can rewrite them in the correct way and get the problem right. Okay, so the negative exponent rule tells us if we have any number with a negative exponent, now that could mean a variable of any kind or a base that's a number. If it has a negative exponent, that means we need to rewrite it. Okay, remember that the negative up there means we need to create a fraction. And anything that is negative needs to go down into the denominator so it can become positive. Now, since there's nothing up here, we're going to put a 1 just as a placeholder. Now, the same thing would happen if we were dealing with a base that was a number. We would want to create our fraction. And this part that had the negative exponent would go down into the denominator. And we could have a 1 as a positive. Now we talked about a coefficient. So let's say I had a number out in front that was not the base of the negative exponent. In this case, the negative part is the base and the exponent together. So when we create our fraction, the part with the negative exponent goes to the bottom. But this 3, it doesn't have a negative exponent, so it doesn't need to go to the bottom. In fact, because it's positive, we're going to let it go to the numerator, like that. So as we're going through our study guide, if we see a negative exponent as our answer, we will fix it. Now, if we see negative exponents before that, we're going to solve it first, and then we'll deal with the answer. Okay, now the next thing we're going to take a look at is the zero exponent rule, which states that any number to the 0 power is 1. Which means if I had a base like 3 to the 0 power, that would be 1. But what happens if I have a coefficient like 2, and then I had x to the 0 power? What do we do then? Well, let's break it apart. We know that this part right here is equal to 1, and this part right here is equal to 2. And that those two numbers are being multiplied together. It's not 21, okay? Those two numbers are being multiplied together. So we could just take the coefficient times 1. 2 times 1 is 2. Okay, so now that we are familiar with our negative rules and our zero rules, we're ready to go through our study guide, and we're going to try some problems together and check and see how we're doing. Okay, so first, the multiplication rule. Okay, so we're dealing with multiplication of numbers with exponents, and the shortcut is what? That's right, we need to add the exponents. Okay, now you're going to take a minute, and you're going to try number 1, 2, 3, and 4. Go. Alrighty, now if you've done this correctly, the first one, -4 plus 3, should give you a -1. Now, we are not done yet. We just got a negative as our answer. That means we need to do what we were doing earlier and take that negative to the denominator. So let's do that. We're going to take that negative to the denominator. And it's 3 to the 1 power. And we can leave a 1 up here as a placeholder. Excellent. Let's go to the next one. We have -2 plus -2 plus -3 gives me 3 to the -7th. Woo, we're going to have a lot of negative answers today. So again, take that negative, bring it to the bottom in the denominator. There. Now we're ready to look at number 3. Number 3 has the case of the hidden ones. There are ones there. We also have some numbers out in front. Okay, so remember we have to deal with the numbers out in front, just like regular multiplication. 3 times 3 gives me 9. And then I can do the adding rule with the exponents. Keep the base of m and add 1 plus 1 is 2. All right, that's a positive exponent, so I don't have to do anything. Moving right along. Number 4, we again have these numbers out in front. So we're going to go ahead and multiply those. 4 times 4 is 16. Then we're going to add our exponents together. Keep the base of m. -3 plus -3 is -6. Now, here we have another negative as our answer. So let's fix it. Now, the m to the -6 is part of the negative. So it's going to go to the denominator. M to the -6. The 16, however, has no negative exponents right there. In fact, it's positive. So we're going to take it, and it goes in the numerator as having a positive exponent. Excellent, excellent. So that is the multiplication rule. Any questions here? Awesome. Okay, so we go next to the power to a power rule. Okay, so looking at these examples right here, what is my shortcut? My shortcut is I need to multiply the exponents together to get my final answer. So your turn to do number 5, 6, 7, and 8. Go. All right, let's check your answers. For the first one, we're going to go ahead and do -2 times 2, which is -4 is my exponent with 4 as the base. We should be getting good at this. We've got a negative exponent. Let's fix it. There, 1/4 to the 4th. Now, 6, we have 3 times 0 is 0. And anything to the 0 power is 1. So the answer is 1. Now, the next one, we have a number out in front of our coefficient and our base. Okay, so what we have to do is we need to take 4 squared, which is 16. Then we need to do 3 times 2 gives me 6. Now that's a positive exponent, so we're good to go. Let's move right along. This one says we've got a 2 out in front, so I need 2 to the 3rd power, which is 8. Then we take r, we multiply these two together. 2 times 3 is 6. Now there is our power to a power rule. Any questions here? Excellent, excellent. Okay, so let's keep going. We're going to take a look at our last rule, the division rule. Okay, the shortcut here is to do what with the exponents? Subtract the exponents. Okay, so now your job is to do 9, 10, 11, and 12. Go. All right, let's see how you did. When we are dividing, we're going to do -3 minus -3, and I get 3 to the 0 power. Oh, that is a little bit blurry right there. There we go. Now, anything to the 0 power is going to equal 1. Done. Now this one right here, there's no exponent right there. So we'll put the 1 there. And then we'll subtract. 1 minus 2 gives me -1. Now because it's a -1, I have to rewrite it as a fraction with this on the bottom. There, all better. 1 over 2 to the first power. Now, we're going to go ahead and take a look at this one. This particular problem, we have some numbers out in front. We have those coefficients. 3 divided by 4 does not come out nicely. So we're going to go ahead and leave that as a fraction, 3/4. And then we're going to subtract with the variables. V4 minus 3 is 1. Now, because we have a fraction right here, you might notice this is not a negative, so it's not going to go in the denominator. You might notice on a multiple choice test that the positive exponent hangs out in the numerator with the 3. These are the same thing. A negative would have hung out in the denominator, but because this 1 was positive, it went to the numerator. Okay. Last one for this section. We have 3a to the 4th and 4a to the 0. Again, 3/4 does not divide very pretty, so I'm going to leave it like a fraction and do the subtraction. 4 minus 0 gives me a to the 4th. Again, because it's positive, you may see the a in the numerator part either separate like this or as part of the fraction in the numerator. These are the same thing because it was a positive exponent. Now we get to the fun part. It's time to do more than one rule at the same time. So if we remember correctly, we're going to look for our parentheses. After we do everything inside the parentheses, we're going to look for multiplication and division. Now number 13 has a whole lot happening inside the parentheses. So we're going to have to attack everything inside here one step at a time. Okay, go ahead and try it. Go. All right, so the first thing we're going to want to do is inside has multiplication. So we will take 2 to the 3rd and 2 to the 0, and we will get 2 to the 3rd power because 3 plus 0 is 3. Then in the denominator, I have 2 to the 1th power because the 1 is hiding. Then I could put these parentheses around it with the -4 on the outside. Now, I'm still needing to solve what's on the inside of this parentheses. So I'm going to subtract 3 minus 1 gives me 2 to the 2 power. And we still have a negative 4 on the outside. Now I've done everything that is inside the parentheses. All that's left to do is the power to power rule, where I need to multiply those two together. So I'm going to get 2 to the negative 8 power. Now, negative 8, we're going to need to fix that so that it is in the denominator, just like that. Voila, we are done. Okay, you're on your own for number 14 because we need to talk about number 15. So pause for a minute and do number 14 on your own. Excellent. Okay, now go ahead and move right along to number 15 and we'll get that checked with Miss Jones later. Number 15 is an interesting problem because it's very much like this one, but we have coefficients out front. We're going to have to deal with those coefficients while we solve. Okay, so we're going to take the same idea as before. We're going to do our parentheses first. Okay, we need to take 2 to the 0 power. Well, this whole thing to the 0 power is 1. Because anything raised to the 0 power is 1. Well, I noticed something else interesting. Don't we have another to the 0 power? That is also 1. So in the denominator, I have 1 times 1, which is 1. So I really just have 2b squared divided by 1. So our answer is 2b squared. Alrighty, now looking at this one right here, it is a little bit more complicated because the everything to the 0 power is located kind of in the middle, and there is still some exponents to deal with. So give this one a try. All right, now remember, also have Miss Jones check and see how you did at the end of that one as well. Okay, now we've got our level 4 questions. Okay, instead of solving, just like using our rules, how we've been doing, we're going to fill in the blank and we're going to figure out what would make the problem true. So if I had a division problem, what exponent could go right here to make this problem true? Then we're going to do the same thing with this problem. Excuse me.